Sequences. A sequence is a listing of elements of some set. A sequence can either be finite or infinite, but here we are most interested in infinite sequences. Typically, the elements of a sequence belong to the set Z, the integers, or R, the real numbers. An infinite sequence is often denoted by a sub 1, a sub 2, a sub 3, and ... meaning going on forever, or by set brackets with an a sub n in them. Example: consider the sequence where a sub n is defined by the statement a sub n equals 1 over 2n for n an element of the natural numbers. We recall that the natural numbers are the counting numbers starting with 1, 2, 3, 4, and so on. We see that when n is replaced by 1, we have a sub 1 equals 1 over 2 times 1, which equals 1/2. When n is replaced by 2, we have a sub 2 equals 1 over 2 times 2, or 1/4. When n is replaced by 3, we have 1 over 2 times 3, which equals 1/6. So the sequence can also be written as, we use set brackets and then list the elements, 1/2, 1/4, 1/6, and so on in the same pattern. Example: determine the first three terms of the sequence a sub n, where a sub n is equal to n cubed minus 2n plus 1 for n an element of the natural numbers. Solution: we'll start with a sub 1 and replace n by 1 wherever we see an n, and we have a sub 1 equals 1 cubed minus 2 times 1 plus 1. 1 cubed is 1, minus 2 times 1. We have 1 minus 2 is negative 1, plus the final 1 equals 0. A sub 1 is 0. A sub 2, we are replacing n everywhere we see it in the definition by 2, so a sub 2 equals 2 cubed minus 2 times 2 plus 1. 2 cubed is 8, minus 2 times 2 is 4, 8 minus 4 is 4 plus 1 equals 5. A sub 2 is 5. And the third term is a sub 3, which is replacing every n by 3. 3 cubed is 27, minus 2 times 3, which is 6. 27 minus 6 is 21, plus 1 equals 22. A sub 3 equals 22. So the first three terms are 0, 5, and 22. A geometric sequence is a sequence in which the ratio of every two consecutive terms, a sub n and a sub n plus 1, is some constant r, that is, a sub n plus 1 divided by a sub n, that's the ratio, equals r for every n which is a natural number. And you see that a sub n and a sub n plus 1 are consecutive because whatever n is, n plus 1 is 1 bigger. So for example, if n is 2, we have a sub 2 and a sub 3, and those would be consecutive. Example: here is a geometric sequence 3, 9, 27, 81, and so on in that pattern. Notice that when we take any two consecutive integers, putting the latter one in the numerator, a sub n plus 1, we have 81 over 27, those are consecutive. 27 over 9 is a ratio of two consecutives, and 9 over 3 is a ratio of two consecutives. And in every case, we get that r equals 3. So, determine the nth term of the sequence a sub n. Well, this one is pretty simple. We see that a sub n should be 3 to the n for every n an element of the natural numbers. And if we check that with the example above, the first term is 3, and the first n is 1. 3 to the 1 is 3. Then we let n be 2. 3 squared is 9. Then we let n be 3. 3 cubed is 27. Then we let n be 4, and 3 to the 4th is 81. An arithmetic sequence is a sequence in which the difference of every two consecutive terms, a sub n and a sub n plus 1, is some constant k. That is, a sub n plus 1 minus a sub n will equal k for each n which is an element of the natural number set. Here is an example. 5, 9, 13, 17, 21, and so on is an arithmetic sequence. And if we start looking at the differences of consecutive terms, 17 and 21 are consecutive, and 21 minus 17 is 4. 17 minus 13 is 4. 13 minus 9 is 4, and 9 minus 5 is 4. 4 is our k, the constant difference. Determine the nth term of this sequence a sub n. Well, the solution is a sub n equals 4n plus 1. And you might have to think about that for a little bit. But if we just did 4 times n, we almost have the sequence, because we do 4 times 1 is 4, and 5 is 1 bigger. 4 times 2 is 8, and 9 is 1 bigger. 4 times 3 is 12, and 13 is 1 bigger. 4 times 4 is 16, and 17 is 1 bigger. And 4 times 5 is 20, and 21 is 1 bigger. So if we take the natural numbers in order, multiply them by 4, and then add 1, we generate this arithmetic sequence.